my name is Progress, and I welcome you all to my YouTube channel. So today I'm talking about indices in mathematics. Indices. Indices is a broad topic in mathematics that extends to various areas. So it is not a difficult subject at all, because it is alright, it's just an upgraded fraction, not a difficult subject at all. So first of all, before we delve into solving problems on indices, we need to talk about the laws of indices. And indices have 7 basic laws. 7 basic laws. I know in my last video I talked about how indices relates with logarithm. Now, but I'm not going to talk about that aspect again, alright? So you can just go to my other videos and check for it. You will find logarithm topic there. Now here, the first law of indices, like in logarithm I talked about addition law and subtraction law. Here I'm talking about multiplication law and division law on indices. For example, we are having a to the power b multiplied by a to the power c. Because they are having the same basis, we can take one and add up the power because it is multiplying the base. So I can take one and add up the power. This becomes b plus c. You get? Now for example, we are getting 2 to the power 2 multiplied by 2 to the power 3. This equals what? 2, take 1, 2, because we have similar bases, and multiply the powers, add the power, 2 plus 3, and that becomes 2 to the power 5. Now let us check if this law is true. For in our normal this is an index, alright? We represented a number in its index form and gave us this one. And what's that be? Because 2 to the power 2 means 2 multiply itself 2 times. And when 2 does that, we get 4. So 2 to the power 2 is 4. Multiply by 2 to the power 3, meaning 2 multiply itself 3 times. And when 2 does that is 8. So 2 to the power of 8 is what? Is 32. 32. And the index form of 32 is what? 2 to the power 5. That's to tell us that that law is basically true. Alright, it's true. Now, that is an explanation in the first law. Now, the second law is the division law. For example, we are having a to the power b divided by a to the power c. It becomes what? A to the power of b minus what? Minus c. So this is just how the law looks like. Then let's say for another example, let's say 2 to the power 3 divided by 2 to the power 2, the previous one we used. I can take one of the bases and subtract the power because the divided is 3 minus 2, and it becomes what? 2 to the power 1, and that is the same as what? 2. I'll give it under the law. So whatever you see in a base to the power 1, anything to the power 1 is equal to that thing. It is fundamental. Alright, now, so let us take it again. So 2 to the power of 3 is what? Is 8 divided by 2 to the power of 2 is what? Is 4. Now 8 divided by 4, observe it gives us 2. 2 to the power 1, same thing as 2. Alright, and that is the explanation of the second law. The third law of indices says that whenever a base, let me use a base I'm not using it. X is a universal preference, okay? Now, but it is not it's not compulsory. So x to the power of 0, whenever a base or any number is raised to the power of 0, that thing is what? 1. So 1 million to the power 0 is 1, 50 million to the power 0 is 1, and so on. Now number 4 law, the fourth law of indices says that it's called a reciprocal law, or you can call it the law of reciprocal, or you can call it what? The law of what? Of reciprocal. That for example, whenever you are having a to the power of a negative, let me use b to the power of a negative 1, like this, a negative value. Then to remove this one, negativity, I need to be having something like b to the power of 1, because we have not seen anything like negative 1 before. Alright? So I need to be thinking of how I can eliminate this negative. So by reciprocating this value, I'm getting 1 all over b to the power of what? 1. So when I take it backward, it becomes b to the power of negative 1. Okay, what about if it is something like b to the power of negative 2? So it becomes 1 over, did you get? What about if it is b to the power negative 2, like I said? So it becomes 1 over 2. If it is b to the power negative 10, it becomes 1 over b to the power of 10. So we have succeeded in removing the negativity. Do you want explanation of that? Don't worry, okay, let's just do it. Alright, for example, we are having let's say 4 to the power of 2 to the power of negative 3. This becomes what? 1 upon 2 to the power of 3, and that is what? 1 over what? Over 8. Yes, so just an explanation, alright? We just started solving the problem. Now, number 5 law, the 5th law of indices, says that whenever that I like using x to the power of a into b. When you see something like this, you know that bracket means multiply, right? So in this context, or in this case, I can easily say I will multiply this a by the b. Yes, I can multiply the a by the b in this case now. For example, you have something like 2 to the power of 3 multiply into 2 to the power of 3 to the power of 2. Are you getting it now? That I'm multiplying another power 2. So I can say this is equals to what? 2. There's no that base here. 3 multiplied by 2, that is what? That is 6. Alright, so that is 2 to the power 6. So the 6th law of indices, or let me see, before we go into that one, what about if in case we are raising to the power of fraction? For example, 2 to the power of 3 into another power of 1 over 3. Then I can multiply it by saying this is 3 multiplied by 1 over what? 1 over 3, and that becomes what? 3 cancel 3, I'm having what? Just 2 to the power 1, and that is 2. Okay? So what about if we're adding 2 to the power of a fraction multiplied by 2 to another fraction? 2 to the power of a fraction, close bracket, into another fraction. How do you do it? We solve it like that, okay? Now, number 6th law of indices. The 6th law says that if this is a to the power of what? 1 over 2, or whatever the case may be, whatever fraction we're having there. So we are going to be having the square, because it's 2, the square root of a, all raised to the power of what? To the power of 1. Alright? Now what about if it is to the power 3? It becomes the cube root of a to the power of 1. What about if it is 2 over 3? It becomes what? The cube root of a to the power of what? 2. What about if it is 5 over 6? It becomes the 6th root of a to the power of what? Power of 5. So whatever the case may be, just the bottom, the denominator root of a to the power of the numerator. The denominator root of a to the power of the numerator. The x, 1 over x, becomes the x root of a to the power of what? Power of 1. Then the 7th law, I've explained it, okay? I just explained it that if in case it's another value to power k multiplied by b to power of x, b to power another k, then we can do what? I will multiply the base, a multiplied by b, and I will take 1 power k. Did you get? So when you see something like this, I can multiply the base and do what? Take 1 power. Did you get? But in the case of the powers, I will take 1 base and add up the powers. Alright? What about if they are different? What about if they are different? Yes, if they are different, we solve it in a different way. Yes, now let us move on. Now to some problems. We solve 2 problems and we call it a day, alright? Because I realize that some of us don't enjoy watching too lengthy videos. Alright, now let's take 3 questions, then we call it a day. Alright, now the first question here asks us to solve. They said solve or find the product of 27 over 5. Example, find the product of 27 over 5, 3 to the power of negative 3, then and 1 over 5 to the power of negative 1, and 1 over 5 to the power of what? Negative 1. So from here I can say this is what? making everything index, we need to practice the law of indices. Though I said it's an obligated fraction. Alright, to clear all that, I'm going to solve it in a fraction way and in what? Indices way of solving it. Now this becomes what? 3 to the power 3, 27 over 5. Then multiply by product. Remember, product means multiplying. So I don't just like writing the whole question. So I dictate the question, write the figures out, and we deal with it as it is. Alright? Now this becomes what? 3 to the power of negative 3 multiplied by what? This is the indices way of solving it to multiply by what? 1 over 5 to the power of negative 1. Remember, since it is to the power of negative 1, I can invert it according to the law of reciprocal. I said if it is this one that is to the power of negative 2, then I can invert it to become what? This one. Alright? And by so doing, every time I invert, negative sign change to positive sign and positive sign change to negative sign, as the case may be. Alright, now let us move on. This becomes what? 3 to the power of negative 3 all upon, okay, let me say multiply by, watch this, multiply by 3 to the power of negative 3. Then what? I'm taking this one up, or let me just say multiply by what? By 1 to the power of negative 1. Of course, that guy even look like a disturb. 1 to the power of negative 1, if I invert it, because 1 over 1. That's all, alright? Now, all over, this is 5. Multiply by what? 5 to the power of what? Negative 1. Okay, we good. Now, this is equal to 3 to the power of negative, positive 3 multiplied by 3 to the power of negative 3. This becomes what? I can take 1, 3 and what? Find the sum of the two powers. Then it becomes 3 plus into minus 3 all over. Take one base and find the sum of the two powers. Remember, anything standing alone is standing to the power of what? Power 1. So it becomes what? 1 plus into what? Negative 1. So what I get here? I get 3 minus 3, and that is 0, right? 3 minus 3, that is 0 all over. 5 minus 1, 1 minus 1, that is what? 0. And we'll have what? Remember the third law says that any base raised to the power of 0 is 1. So 3 to the power of 0 is 1 over 5 to the power of 0 is 1, and that becomes what? 1 as our final answer. Alright, let's move on. So after this video, I expect each and every one of you to go on revising past questions, handling them. When you see a difficult problem, you can send it to my WhatsApp, www.whatsapp.com. Then you give me a text message, alright? You DM me. Okay, the second question. Here we ask to find the value of alright. Now let's just simplify the expression. Simplify the expression. Simplify the expression. 2 to the power of half multiplied by 3 to the power of half. 2 to the power of half multiplied by half multiplied by 3 to the power of what? Power of half. Multiplied by 6 to the power of half. 6 to the power of half. Multiplied again by 8 to the power of 1/3 and 27 to the power of 1/3. 8 to the power of 1/3 and multiplied by 27 to the power of 1/3. Alright, remember that to the power of half, to the power of half is the square root of that value. Do you get? So the smallest number that can be here is 2. And once it is 2, there is no need writing it again. Okay? Once this is 1 over 2, and I'm expected to write 2, since 2 is the smallest value I can put here, there is no need writing 2 here again. As just like 1 is the smallest value a number can be raised to, there is no need writing 1 again because it's the same thing. And 1 is the smallest value that can be dividing any number, so there is no need writing that number is being divided by 1 again. Alright, so here is 2 to the power half, 3 to the power half, yes, then 6 to the power half. But you will agree with me that there is no possibility of getting the square root of 6. Okay? And we can get this one. the cube root of 8 as what? As 2. We can get the cube root of 8 as 2, and we can get the cube root of 27 as what? As 3. Alright? So automatically you are doing that. When I said, you are looking me when I said this, there's no need writing 1 here again, because any number standing alone is standing to the power of 1. Here I can also write 2 as to the power of what? 1. But there's no need writing it. But when the case arises, I will what? I will write it. Now let me proceed. So this one is already simplified. There is no need finding the square root of 2 again. It's already simplified. Multiply by, there is no need finding the square root of 3 again. It's already simplified. But 6 is our bane of contention. 6 is our bane of contention, because the square root of 6 is going to give us a decimal number. Also, likewise, 2 and 3. Alright? But I'm going to do it this way. You will agree with me that 6 can be given as 2 multiplied by 3. And this is all to the power of what? Half. Yes, that is how we handle questions like this. Multiply by, what did I represented? What is the cube root of 8? Remember, it becomes what? 3 in third root of 8 to the power of what? To the power of 1. No need writing it. Because 3 is not the smallest number I can put there. 3 can be shown. 3, in fact, it should be shown. Alright, this becomes what? This becomes 2. Remember, it's equals to 2. It is 2 that will multiply itself 3 times to give us 8. So it becomes 2 multiplied by, it is 3 that will multiply itself 3 times to give us what? 27 multiplied by 3. Alright? That's for our second step. Then the next step, this is, I can write this one down, multiply by 3 to the power of half. I can write it down, multiply by, remember, this guy is to the power of 1, this guy is to the power of 1. And from this law number 5, I said if a base is to the power, is raised to a power into another power, then we can multiply the first power by the second power. So half will multiply 1, half will multiply 1. Yeah? So I'm left with what? 2 to the power of 1 times half is half. Multiply by 3 to the power of 1 times half is still what? Is still another half. Multiply by 2 and multiply by what? By 3. Now here becomes what? I can take all this we call it like terms. All like terms should be in one side, alright? For easy identification. Like terms 2 and half, another 2 and half, and what? Another 2. They are like terms. Multiply by 3 and half, multiply by another 3 and half, multiply by another 3, another like terms, alright? So I can take one base here, take one base here. We are good to go. It becomes what? 2 to the power of what? Half plus what? Of course it's 1. Yes. So this becomes half plus 1. Multiply by 3. Here again, half plus 1. Yes, that's how to do it. Now, automatically this over 1 and this was over 1. Remember I said any number standing alone is standing over 1. Since it is the smallest number that can be there, when the case arises, I can put it there, I can affix it. Now here becomes what? I'm going to solve here in a fraction way and solve here in another word, fraction form. It becomes what? 2 to the power of what? Take a really long line. Find the LCM of the denominators, and that is 2. 2 divided 2 multiplied by 1, that is 1, plus 2 divided 2 multiplied by 1, that is 1, plus 2 divided 2 multiplied by 1, that is 2. Then multiply by 3 to the power of rule a straight line. Similar occurrence is going to happen here. 1 plus 1 plus 2. Yes, 2 divided by 2 multiplied by 1 is 1, plus 2 divided by 2 multiplied by 1 is 1, plus 2 divided by 1 multiplied by 2 multiplied by 1 again, that is 2. Okay. Now, sum of the denominators in the power. The numerators in the power, we are having 4 over 2 multiplied by sum of the denominators in these powers, we are having same what? 4 over what? Over 2. And it becomes what? 2 to the power of what? 4 over 2, that is what? 2 multiplied by, it becomes what? 4 over 2 becomes what? 2. Remember, this 3 to the power 2, sorry. Remember, the 7th law says that since we are having similar powers, I can take one power and multiply them. That becomes what? 6 to the power 2. And what is that value? 36. Our answer is 36. But if your answer happens to, if your option happens to give you your answer in this form, this is your answer. If the option happens to give your answer in this form, this is your answer. If your option happens to give your answer in a whole number, not in index form, 36 is definitely your damn answer. Alright. Now I can take it off. My teacher will say, I want to take my tin off. I want to take my tin off. So I have taken away my tin now. I've taken away my tin. Alright, let's dive into the next question. The last question for the day, and we call it a close. So what are we going to handle now? What question are we going to be facing now? Here I said evaluate a to the power of 1/3 multiplied by 5 to the power of 2/3 all upon 10 to the power of 2/3. This is what it says. Evaluate a to the power of 1/3 multiplied by 5 to the power of 2/3 all upon 10 to the power of 2/3. Now I'm going to take this part separately, finding the cube root of 8, then I'll find the cube root of 5 to the power 2, and find the third root of 10 to the power 2. Definitely these two guys are what? And undefined. I will put it in that form. It's not possible. They're going to give us decimal numbers. But there is a way we can evaluate this question. So I can meander my way through this question by saying, here is 2. You know this is what? The third root of a to the power of what? Power 1. We're going to be writing that 1. It's 2. 2 times 2 times to give us 8. Alright, then multiply by 5 to... Remember I said since it's going to give us the decimal number, if we write that decimal number, we are going to be facing hell of problems, giving ourselves work to do. Now, all of remember like I did that question, 10 can be given as what? 2 multiplied by what? 5, all to the power of what? 2/3. Alright. Now this becomes what? This becomes 2 multiplied by 5 to the power of 2/3 all upon, yes, multiplying this is what? 2 to the power of 2/3 multiplied by 5 to the power of what? 2/3. Okay, I'm going to split this fraction in this form, like this. Alright? Remember, when you are multiplying two fractions, if there is a possibility that when two fractions are multiplying each other, the denominator multiply the denominator and the numerator multiply the numerator. In that form, this is the case. And in revising it to that case, we have what? 2 over 2 to the power of what? 2/3. Then multiply by 5 to the power 2/3 all upon another 5 to the power of what? 2/3. Now I can take one because it's dividing here, like this number 2 law. I can take one. Remember, all of that means divide. So that implies that this becomes what? Taking one of these, 2 to the power of what? 1 minus 2/3. Then what? Multiply by what? 5 to the taking one of the 5 and subtracting the power 2 over 2/3 minus 2/3. Alright? Now this becomes what? 2 to the power of what? Already, if you are asking me to evaluate this problem, I will tell you this is what? 1 over 3, that is 1/3. But let us solve it for simplicity sake, for understanding sake. Finding the LCM, this is 3. 3 divided by 1 multiplied by 3 is 3. Minus 3 divided by 3 multiplied by 2 is 2. Then multiply by 5 to the power of 10, taking similar denominators, and 2 minus 2, that is 0. So 2 to the power of what? Of 1 over 3 multiplied by what? 5 to the power 0 over 3. Alright? Now this becomes 2 to the power of 1 over 3 multiplied by 5 to the power of 0 over 3 is 5 to the power of 0, and that is what? 1. So this value multiplying 1 is the same thing as this value. So our answer ends up giving us, either you say this is 2 to the power of 3, or you can say the answer is what? Then the root of 2. So whichever way you get your answers, whichever way the option gives you your answer, this, pick anyone, and that automatically becomes your them answers. Alright, now let us continue. This is the last question of the day. So I'm going to drop one question, and from that question, you are going to solve it on your own and send to me your answers. Make sure you have subscribed to my channel by then. Hit the notification button and you get more of my videos each and every single day and time I upload a new video. So here is the question. They said we should solve the third root of 64 arrow to the power of what? -6, all multiplied by 1 upon 2. I think that's the question. Yeah, that was the question. Alright, so see you all in my next channel, in my next video, sorry. Bye.